What's up, my mathletes? That's right, this is Miss Muscarella coming at you. And in this video, we're going to take a look at the quadrantal angles and radians, and we're going to look at the pi over 3 family as we do that. So let's just kind of talk about quadrantal angles here again for a moment. Now, the quadrantal angles, they're going to be the ones that are sitting on the x-axis or the y-axis, which you can see highlighted here in green. They are in degrees, so we have 0 and 360, 90, 180, and 270. Now that's in degrees. However, if they are in radians, then they're going to be a different unit, right? So we're going to have 0 and 2 pi. We're going to have pi over 2 and pi, and then 3 pi over 2. So if it was in that pi over 2 family, then, you know, that's what we would have going around. So we'll talk a little bit more about that later. But we're going to do the pi over 3 family today. So let's kind of think about this for a second. We're just going to look at the ones on the x-axis first. So this spot right here is 0. And then over here is pi. Now, if we are dealing with the pi over 3, so a lot of times when you have to sketch angles or work with a different unit that has a fraction like that, you've got to be able to do some converting here. So pi is going to be the same thing as 3 pi over 3, because if you reduce that, that would just get down to pi. And of course, 0, that just stays as 0, man, because that doesn't do anything. Now, here's where we got to do some things here. So this could be 2 pi. That could be 4 pi, 6 pi, 8 pi, and on and on and on it goes, right? So that pattern goes there. Now, 0 and 2 pi, 0 would be the same thing in the pi over 3 family as just 0. So that doesn't change, because if you had 0 pi over 3, we're not going to write it as that. We're just going to write that as 0, okay? But if that was 2 pi, so if we went around the unit circle one full time or did one full revolution and came to that spot and at 2 pi, so you want to think about it and look at the denominator, right? The denominator is 3. So what would reduce down to give you 2 if you had a 3 on the bottom? So if you had a 3 on the bottom, what has to be on top so that it gives you a 2? And that would be 6 pi over 3. Then we kind of look at the same idea with 4 pi. So again, it would have to be that pi over 3 piece is going to be there, but what would have to reduce down, what would be the numerator of that, right, to end up giving you 4? And of course, that would be 12, because if you took, so I'm going to highlight it right here, if you took the 12 and a 3 and reduce that, that would get you to this 4 right here. So I think you're probably getting the pattern by now, right? So 6 pi over would be the same thing as 18 pi over 3. And 8 pi would be the same thing as 24 pi over 3. So see, that's basically it right there. That's basically it. And notice the difference here between these consecutive ones. So I have 0 to 2 pi, right? So that's the difference between two consecutive ones. Or if I go 4 pi to 6 pi, the difference between two consecutive coterminal angles is always going to be 2 pi. Well, same thing if I'm in radians, working with a different fraction here. 0 to 6 pi over 3, that's going to reduce down to 2 pi also. So that distance is 2 pi. Same thing if I went from, say, 18 pi over 3 to 24 pi over 3. Again, those are consecutive, so it's one right after the other. Then that would also be 2 pi. But let's talk about the other side where we have 3 pi over 3. So part of that pattern, if we look at the distance between there is 2 pi. So if I had pi to start with, and I added another 2 pi to that, that of course would give me 3 pi, right? So this would start out being 3 pi, but what is the same thing? So I'm going to make it like that. What's the same thing? So if it reduced, would end up giving me 3 pi. And that top number has to be, what? 9. And then if we had another 2 pi to the 3 pi, so again, this is just, coterminal angles. You're just going to subtract 2 pi, right? So in this case, we're just adding it. So if I add that, now I'll get 5 pi. So now, all right, if I take a look at that, so now I have 5 pi. And that would be the same thing as how many pi's over 3? Well, what divided by 3 gives you 5. And of course, that's Musky's favorite number, 15. Number he wore in both high school and college playing ball, playing soccer. Good old Fredonia State University, man. Go Blue Devils. So, and that'd be the same thing. Next one would be 7 pi. And then, of course, you should know what divided by 3 gives you 7, and that would be 21. So we'd have 21 pi over 3 would be the same thing as 21 1 pi over 3 is the same thing as 7 pi. All right, and that's not too bad for the ones that are on the x-axis. The y-axis, though, this one is where sometimes it takes a little bit longer to figure out, right? So what we're going to do is take a look at this top number right here, the numerator in 3. So if you think about it kind of from a number line perspective, you start out with 0, and then you go to pi, right? So 0 to pi, we know if we took half of the distance between there, so half of that, if we were to divide that in half evenly, well, that would just be pi divided by 2. But we're doing things a little bit differently, right? So we've got that 3 pi over 3 is going to be the same thing. So 0 to pi is going to give us half of that distance. Now, if I take a look at the numerator is 3. What's half of 3? Well, that'd be 1.5. All right, so this would be the same thing as 1.5 pi over 3. 1.5 pi over 3. Now, again, remember, how much did we add to each one each time? So let me go back here to the consecutive ones on the side. So I'm going to highlight it over here in green. On this side over here, right? So we're going to look at 2 consecutive ones. Each time, what was the distance between these 2 consecutive ones? Well, if you look at 9 and 15, their difference is 6. And if you look at the distance between 15 and 21, their distance is also 6. So whenever you have coterminal angles, you're always going to add or subtract 2 pi, right? Or in this case, because we're dealing with thirds, we're going to add 6 pi over 3. So if we just add 6 pi at the top, we're going to get 7.5 pi over 3. 7.5 pi over 3. And then if we add another 6, then we would be at 13 pi over 3. And if we had another 6, then we would be at 19 pi over 3. So these are all different coterminal angles because you might have to revolve around several times. All right, now let's go to the bottom value. So the bottom value, we're going to take a look at this number right here, this 1.5, and we're going to add that to 3. We're going to add that to 3. And that's going to give us our very first number here on the where normally 3 pi over 2 is. So 1.5 plus 3 gives us 4.5 pi over 3. Because again, if you reduce that down, then you'd end up with 3 pi's over 2. All right, but so we're there. And then if we add 6 pi again, then we're going to be at 10.5 pi over 3. If we add another 6 to the numerator, we'd be at 16 pi, 16.5 pi over 3. Ooh, that's sloppy. Yeah, you know Musky would yell at you if you wrote it like that, so let's be neat when we write that. So 16.5 pi's over 3. And then if we added another 6, we'd be at 22 pi.5 pi over 3. So all of those are going to be on the same location. It just depends how many times you revolve your circle, how many revolutions you're going around. So that's for the pi over 3 family. Now we'll do another one in the pi over 4 family, so it'll be very similar. Now if this was negative though, so let's think about this though. So if we were going around the opposite direction, then of course all of your values would be negative, and then you would take the values that are up here and down here and switch them. So the 1.5 pi over 3, 7.5 pi over 3, 13.5 pi over 3, they would all be down here, but there'd be a negative with it. So negative 1.5 pi over 3, and all those other ones, they would be on the bottom of the y-axis. And then the 4.5 pi, so 4.5 pi, that would be in the top, but again, don't forget you're gonna have a negative there. If we were moving in a negative direction, because if we were moving in a negative direction, we go around this way. All right, so that's just a little thing on that. So hopefully that'll help with that a little bit, and we'll take a look at another one in the pi over 4 family coming at you very soon. All right, that's it for this vid, man. Thanks you guys for watching. I hope this helps, and I will catch up with you later. Peace out.